Welcome, polar bears and polar cubs. Let's talk a little bit of review before entering into a new topic. So we're going to think back to chapter 3. We're going to be talking about molar mass again. And then we're going to be talking about molar conversions. So just a reminder that the molar mass is the mass found on the periodic table for the amount in grams that would equal 1 mole of that element. That would then equal 6.022 times 10 to the 23rd atoms of that element. So keeping that in mind, calcium chloride has a gram molar mass of 110.98. How did I get that value? Well, I got that value from the fact that we have calcium at 40. 40.08, and then you have each calcium being 35.45, and there's 2 of them, giving us 110.98. So I'm going to ask that you find the molar mass of these 3. I'm going to go ahead and have you pause it, and then at the countdown, I'll show you the answers. So 3, 2, and 1. So the first one is just magnesium. So you're going to find the molar mass of magnesium on the periodic table, which is 24.31 grams per mole. On magnesium chloride, you have MgCl2. So you're going to take the 24.31. You're going to also add 2 chlorines, so that's 35.45 times 2, giving you 70.90. Add together, you get 1, you get a 2, carry the 1, 5, and 9. So you're going to get 95.21. On the last one, it's magnesium chlorate. Chlorate being ClO3 minus. So you're going to get Mg parentheses ClO3 2. So you can actually take, since we have 2 Cl's, you can take the 24.31 plus the 70.90 from above. Add that together, get your 95.21. And now we need to add the oxygens. There's 6 oxygens, so oxygen is 16 times 6, giving us 96. So we're going to get 0.21, 1, carry the 1, 191.21 for the molar mass. And that should all be review. Also part of the review is representative particles. You've heard these ones before: atoms, ions, molecules, formula units. Now we're going to actually tell you where they correspond, what they would correspond to. So when talking about atoms, you're talking about a singular element. So atoms go to a singular element. Molecules go to molecular compounds or the diatomic molecules. So 2 nonmetals make a molecular compound, or the 7 Diatomics, also known as the pesky 7, are molecules. Formula units is anything that's ionic. So it's a metal plus a nonmetal or polyatomic. For some reason, this doesn't want to work. There we go. So, and then ions is anything that has a net charge. So, whether it's positive or negative. So, we're going to go through the left-hand side, and then I'm going to have you go ahead and try the right. So, barium plus iodine, that's a metal plus a non-metal, so this makes it a formula unit. A good abbreviation for formula units would be form units. K, well, that's just one element, so that would be atoms. PO4 minus 3 has a negative charge, so it must be ions. Aluminum chloride, again, is a metal in aluminum and a nonmetal in chlorine, so that would be form units. All right, go ahead and try 5 through 8. 3, 2, and 1. So for 5, we're going to have molecules. For Hg, it's atoms because it's mercury. For NO, it is also molecules. For Cu plus 2, since it has a charge, it would be ions. All right, and that is representative particles. A new way that we want you guys to be able to see the mole, and we're going to kind of get into these kind of problems by showing the math here in the next few days, is mole interpretation. So what we want you to understand is that if I have 1 mole of sodium carbonate, how many, if I broke it down, how many formula units of it would it be? How many moles of just sodium ions would I have? What about the grams of sodium carbonate? What are the grams of just oxygen, the ions of carbonate, and so forth? So, formula units. If you have 1 mole of something, the formula units of it would be 6.022 times 10 to the 23rd, also known as Avogadro's number. Now, moles of sodium. So this one, you're going to look inside of the formula, and if it has a subscript, that's going to tell you how many moles of it you have. So on sodium, there is a 2, so we must have 2 moles of sodium. When it comes to the grams, you're going to add it up. So on your calculator, you're going to take 22.99 times 2. That's for the 2 sodiums, plus 12.01 for the 1 carbon, plus 48 for the 3 oxygens, giving you a grand total of 105.99. Now, how much of that grams, of that mass, would be due from oxygen? Well, there's 3 oxygens, so we take 3 times 16, giving us 48 grams of oxygen. What about ions of carbonate? So you need to look at your formula again, see how many carbonates are there. There's one. So that means that if I have 1 mole of sodium carbonate, I also have 1 mole of carbonate ions. So that means I have Avogadro's number of carbonate ions. When it comes to moles, if I have Avogadro's number of ions, I would have 1 mole. For ions of sodium, you notice that we have 2 moles of sodium here near the top. So we're going to take Avogadro's number of 6.022 times 10 to the 23rd and multiply it by 2, giving us a grand total of 1.204 times 10 to the 24th. We're almost through this mole interpretation of sodium carbonate. The final thing is how many moles of oxygen do we have? If you look, there are 3 oxygens in here. So for every 1 mole, we have 3 moles of oxygen. And the last thing is we need to find the gram molar mass of carbonate. So you're going to take 12.01 for carbon plus 48 for the 3 oxygens, giving you a grand total of 60.01 grams of carbonate. That's going to be on your first worksheet for this section of notes. The next day, we'll focus more on this. The roadmap, it's back. It is back. So you're going to have a worksheet that just focuses on whether you take grams to moles and then moles to particles, or it might ask you some questions where you're taking particles to moles and then moles to grams. This should be review again from late October, early November. So let's work through a problem together. I'll do question number 1. You guys can do question number 2, and then we'll do question number 3 all together. All right. So question number 1 has the mass of 5.63 moles of potassium chloride. So we start out in moles. So we start out with our given over 1 in moles. Now, you need to remember what potassium chloride is. Potassium being K plus 1, chloride being Cl minus. So they just go together. So we have KCl. They asked us to go to mass. Mass is grams. Since it has mole in the problem, it's only one step. So we're going to put mole of KCl on the bottom with grams KCl up top. Mole is going to get the 1. Grams will get the molar mass. Potassium is 39.10 plus chlorine 35.45, giving us a grand total of 74.55. Multiply that by the 5.63, and your final answer is going to be 420. So we're going to write this as 420 with a decimal place. The 7 rounded the 9 up, which then makes it a 2. Add grams per of potassium chloride. Now, I do want to bring your guys' attention to one slight change. We are no longer going to use scientific notation unless it is greater than or uses at least 10 to the 3rd or greater, or it goes the opposite and it is 10 to the negative third or less. All right, go ahead and try the second one, and I'll get back to you with the answer here shortly. 3, 2, 1. All right, on number 2, it asks for the moles of this number of formula units of sodium fluoride, sodium being Na+, fluoride being F-. So we're going to have 7.38 times 10 to the 23rd over 1. This is going to be, you can put F units. Do not abbreviate it further than that. Times. Now, it has mole in the problem, so it is, again, one step. It's going to go to mole NaF over formula units NaF. So we're going to plug in the numbers. Mole is going to get 1. If you have formula units or any type of particle that's not the given, it's going to get Avogadro's number, 6.022 times 10 to the 23rd. So we're going to divide. So you'll take 7.38 exp or times 10 to the 23rd. I hit enter to put that as an answer, divided by parenthesis 6.022 times 10 to the 23rd. And I got a final answer of 1. Remember, its sig figs is 3, 1.23 mole NaF. All right, that was question number 2. So both of those were single step problems. So what happens with a double step? So let's work on this one together. I'm going to change my pen color. All right, so we need to move this over to the left once, making this 24. Iron 2, meaning that has a 2 charge. Sulfate has a 2 charge, so they're just going to come together, giving us FeSO4. So part of the challenge on these problems now is the fact that I give you the chemical name, and you have to know the formula. So let's start. We have the formula units. So we have 1.216 times 10 to the 24th formula units over 1. This is FeSO4. Now, the first step, if it doesn't say moles, is to get to moles. So we're going to put mole FeSO4 over, it's in formula units, so formula units is going to come down. This is also an FeSO4. It is quite important that you start putting these labels on everything, because our next step in this type of math, those labels are key. And finally, we're going to mass, so we're going to end up with grams. FeSO4 SO4 over mole FeSO4. All right, now it's time to put numbers in. So in these problems, moles are going to get 1 automatically. If it's particles, any type of particles, and it's not our given, it gets Avogadro's number. So that would be 6.022 times 10 to the 23rd. For grams, you're going to have to calculate the molar mass. So for iron, it is 55.85 plus sulfur, which is 32.07, plus now 4 oxygens. 4 times 16 is 64, giving us a grand total of 151.92. All right, so what I would do is I would again do that intermediate step. So I'm going to take the tops, 1.216 times 151.92. I'm going to round this to 5. So that's 1.8473 times 10 to the 26th. And on the bottom, of course, I'm going to have Avogadro's number of 6.022 times 10 to the 23rd. Now I'm going to divide. And you should get 3.068 times 10 to the second. And then you're going to move it 2 places over because we don't do 10 to the second anymore. So our final answer would be 306.8 grams FeSO4. All right, and that is single roadmap problems to the fullest extent. Please let me know if you have any questions. If so,